This is Grover, a simulated lunar roving vehicle that is used to develop procedures and to identify problems associated with geologic exploration of the moon. It has been driven by the astronauts to familiarize them with the operation of an actual lunar roving vehicle, or LRV, and to rehearse them for their geologic assignments during lunar surface missions. Because of limited life support systems, astronauts on foot can only go a distance of about 2 miles from the landing site. With an LRV, however, the radius of their exploration can be expanded to about 6 miles, permitting the collection of a much larger sample from the lunar surface. Grover was built in a special vehicle shop at the U.S. Geological Survey's Center of Astrogeology in Flagstaff, Arizona. R.A. Mills, who supervised the construction of Grover, explained some of its features.
This is our simulated portable life support system. It takes up the space at the back of the seat that the real life support system occupies during short sleeve tests. Located beneath the seats are special wire-reinforced cloth storage bags. These are to be used for storage of geologic samples and other small pieces of equipment. Basic navigation information is provided through a gyroscopic heading indicator. This is periodically updated through a sun alignment device. Communications are handled through this low-gain antenna. This is adjustable from the seated position. In addition to a seatbelt as a restraining device while driving on the lunar surface, extra security is provided through the use of Velcro fastening material. These patches are attached between the back of the portable life support system and the back of the seat. These make it slightly more difficult to egress from the vehicle. Breakaway from the seated position is aided by the use of an outboard tow hold. Should failure of a drive motor occur, the outboard tow hold may be withdrawn from its socket and used as a decoupling tool by insertion into the drive mechanism. The Lunar Communications Relay System contains the power supply and the control systems for the colored television camera and the antennas. Aiming of the S-band antenna is a manual operation using this optical device for alignment. While the vehicle is parked, and after initial alignment of the S-band antenna, the color television will be remotely controlled from Earth to observe the astronauts on the lunar surface. Mounted on an extension of the right handhold is the 16mm data acquisition camera. This camera can be operated from the seated position. Primary drive power for the rover is provided through 4 standard automotive-type batteries. Located beneath this case are the steering and driving controls. The power for the control system relays is provided through this 24-volt aircraft battery. For steering, activation of the hand controller sets into motion an electric motor driving this rack and pinion steering gear. Braking of the rover is accomplished through this electric over hydraulic device. The rover suspension is independent with torsion bar springing. Drive power is through 4 individual 24-volt direct current motors, one for each wheel. Final drive to the wheel is through a gear reduction case in the hub. The hand tool carrier presently fitted to the rover is being used for experiments in geological methods. It does not have the same configuration as the flight-qualified unit currently being developed for the lunar mission. To activate the rover for driving, the first step is to turn on battery power. The next will be selecting power for each of the 4 individual drive motors. Next we'll select steering. We have a choice of either normal or crab steering. In this case we'll select normal. And finally the direction of travel, either forward or reverse, and we'll select forward. All of the vehicle control movements are incorporated in a single lever, centrally located so that it can be operated from either seat. Our left steering is, of course, left, and right for the right steering. Brake application is by pulling back on the handle, and forward movement releases the brake and applies power.
Grover will not go to the moon, but it is a valuable tool for training our astronauts to explore the lunar surface more effectively.